This is my wireless volt and current meter, and it's using a Bluetooth connection to send values to my computer. So I'm going to start off by showing exactly what this does. This is essentially a positive and negative voltage terminal that you can use for different things, and it takes voltage in from the back. And in this case I have it hooked up to this variable power supply. So if I bump up the voltage a little bit to about 22 volts, you can see it in detail on the top row. And right now I have about a 1 kilo ohm resistor here on the bottom, so I would expect about 220 milliamps of current. The bottom row is a current meter and it shows that. The display is being displayed constantly using a multiplexed 7-segment LED system, and that pretty much means that only one character is illuminated at a time, and each character has 7 potential LEDs that could be on. So like the 2 has the top LED, the side, the middle one, etc. And inside I have a microcontroller which is interfacing the pins which go to the LEDs. So this module that displays current and voltage is really cheap. It's only a few dollars on eBay, and it doesn't have any type of output other than illuminating the display. So I made kind of a man in the middle here, where there's a little microchip down there. That's an ATmega 328 using a crystal for its time source. I'll talk about that later. And it's directly sampling 16 pins. 16 pins are 8 of which go to the characters, so it determines which character is illuminated, and then 8 more go to the segments. So that's 7 segments for each LED, and also 1 segment for the period. Here's a little diagram of the ATmega 328, and just kind of really briefly, I use the left side inputs for characters 1 through 8, and the right side inputs for segments A through H. A 7-segment display is usually A through G, and I just call the period here H. And yeah, that should be enough. Also, I'm reading that, making the calculation from the microcontroller, and then sending that data through serial port. And rather than use a USB serial adapter like this, which would require me to be tethered to the computer, I'm actually doing it using a wireless serial module, like this one. Let's see if I can pull that out. So this serial module takes in 9600 baud data, and it transmits it wirelessly over Bluetooth. And it requires 3.3 volts rather than 5 volts, and I'm using a little LM7805 here, so my microcontroller is running at 5 volts. And I don't want to send signals directly to this board with 5 volts, so I have a little Zener diode shunt here through a series 1K resistor, and that helps take my 5 volt signal on the input of the white line, and it drops it down to 3.3 volts going to this module. And then that's sent over here to this HC06 device, and these transmitters, by the way, are only a few dollars on eBay. So here they're being sold for about $3 and change with free shipping. And then on my computer I have a USB Bluetooth receiver, and that seems to be all I need to make it work. And I'm not sure why it stopped. Oh, there we go. I had to click a button over here to get it activated again. Sometimes when it power cycles, it needs a little bit of help. But anyway, here is the voltage and current coming out. The voltage is 22.6, the current is 22.7 milliamps, and as I adjust the voltage here, it obviously adjusts the voltage and the current on the front, and that adjusts what's read on the computer. So I'll turn the dial a little bit more so you can see how quickly this updates. It's sending voltage to the computer more often than it's actually being updated. So if I wanted to have a program on the computer to sort of fact check it to make sure that it was receiving the right value, I would just look for duplicate values to be received to know that an accidental character wasn't sent or something like that. So I don't want everything inside to just be floating, so I'm going to go through and hot glue everything down, and that should be just good enough to get everything working. This is the device after it's all put together, and it looks a lot cleaner than it did with all the wires hanging out. I used hot glue to keep everything in place, so I'm confident that it's going to stay where it needs to stay. And normally I could put any circuit under test here using positive and negative, but since I don't have any circuits that are really interesting to look at, I'm just putting a 1K resistor in between. And the top row shows the voltage, and right now it's the voltage of the power supply, and the bottom row shows the current flowing between these 2 points. So since it's a 1K resistor, 6.2 volts will produce about 6.2 milliamps. One cool thing to note is that I have a voltage sense pole right here, and I can switch between sensing the positive power supply voltage or this device here. So, since it's not connected to anything, it just shows 0 as I flip that switch, but it would let me probe something other than the power supply if that's something of interest to me. As I increase the voltage on the power supply here, you can see that the power supply voltage increases, and then the current through the resistor increases as well. This does connect to a computer through a serial port, but it's not using a hardwired serial port. It's got the wireless serial transmitter inside using Bluetooth, which is pretty cool. So I've got this, it's a little wireless USB Bluetooth device. These aren't very expensive. I forget how much these are. They can't be more than a few dollars. And the Bluetooth serial transmitter inside run about $3 and change on eBay with free shipping. So I'm going to show you how I do this here. I plug in the USB card, and using Windows 10 I can open up the Bluetooth control panel, and it should detect my device pretty soon. Just for good measure, I'm going to power cycle this thing, and that'll restart the Bluetooth device, and we'll see if it comes up. There we go. That's the unknown device. So I'll hit pair. And I know from the datasheet that the default password is 1234. So it'll try to connect. And there we go. So let's take a look at the device manager just so we know what ports we're going to be looking for. The HC06 is the module, and the port is going to be under ports. Looks like we're looking at COM 25 and 26. So I'm going to open one of my favorite serial monitoring programs. This is RealTerm, and I'll adjust the port 9600 baud. We'll try a couple of these until one of them works. Looks like it might not be 26. I'll try number 25. There we go. And I'll switch the display mode to ASCII. So now we have our voltage and our current. So again, our voltage is 14.63, our current's 14.5, and those are the numbers that are coming out here. So just to make it kind of drive the point home, I'm going to move this out of the way, put these close together, and I will adjust my voltage here. I'll slowly increase it, and you can see that it tracks on the computer exactly what you see on the meter there. And it's intentionally configured to send data more frequently than is necessary, but that's so we can have a little bit of almost like error checking in software on the computer side, so I can force it to receive the same value multiple times before I commit it to memory, if I'm going to do something like a logging application or something like that. But in any case, this is pretty cool. We have a power supply that is wirelessly monitoring current and voltage, so it's ready to just immediately implement into some type of data logging program. So I look forward to giving this a test on some of the equipment that I have around my shack. So my device is paired and I'm ready to record some information, and now I want to do an actual experiment. So here's the device that I've been working on. I haven't really talked a whole lot about it on my website, but it actually takes a lot of power. Inside of here is a bit of an oven, and I'm measuring the voltage that the oven is getting by probing this connection here. And it should be about 9 volts, but when it's heating up, it's going to drop down really low to maybe 5 or 4 volts. And normally this thing is just powered from this 13.8 volt power supply. And instead, I'm just going to run it through the voltage and current meter that transmits the data wirelessly to my computer. So I'm interested in measuring current and voltage at the same time, which I can't really do with a standard multimeter, even one that has serial output. So this is a really kind of cool application, and one of the goals for having a device like this. If I flip the switch in the back, you can see it shows the power supply voltage, which is about 13 volts, which is something that I would expect. Instead, I flip the switch and it measures the voltage on that gator clip back there, and the gator clip is what's going to that voltage rail. So let's see, the thing that I'll start doing is I'll set realterm to record the data to disk, and we can analyze that later using a Python program. But I'm going to hit overwrite, and now it's recording these values. And now I'm going to plug in this device here, and as soon as I plug it in, you'll see the voltage and current. So I expect it to be kind of a decreasing amount of current, but it's still going to go, the voltage is going to slowly rise as the current decreases. But it'll be really interesting to see how this behaves over the time course of a few hours. If I go to the computer, you can see that the voltage and current that's being recorded to disk is changing exactly like we'd expect it to. So I'll let this run for about an hour, and then we'll take a second look and see how it's looking. So after about 10 or 15 minutes, this thing really mellowed out, and we've stabilized to kind of a low current and then a voltage much closer to 9 volts, which is about what I expect. So in that time, I wrote a Python program which starts here, and it gets data sort of X voltage and current, where X is this time value. Right now it's set for the time axis just to be the number of reads, because my acquisition program was that realterm program, and realterm wasn't configured to save timestamps or anything like that. So it's a little bit arbitrary time axis, but if we wanted to add an actual time axis, we would just make our acquisition software be Python. So it just reads this output file, the capture warm-up file. That's what saves all of the voltage and current readings, and the script just reads that file, creates a figure, makes 2 subplots. Here's subplot 1, subplot 2, makes one of them potential, one of them current, and lets the user interact with it. So I'll run the program, and this is the output. It's pretty simple. The voltage is on the top and the current's on the bottom, and it's kind of cool. So now we can inspect what actually happens. I'm going to start over, and we can observe that around the 0 time mark, there was no current being drawn, and the voltage was 0. That's because I hadn't turned it on yet. I was still recording this video. And then almost immediately when I turn on the machine, the voltage immediately goes up to about 9 volts, and it looks like the current starts out at about 180 milliamps. So I think something is happening here, like the oscillator is warming up for a minute or two before it starts drawing a lot more current. Also, take a look at this voltage. There's a pretty significant voltage drop. I would expect the voltage to be about 9 volts, but here where the current is low, it seems to struggle keeping the voltage high. So maybe this is some type of current limiting built into the power supply that I'm using. We can talk about that in detail later. But the part that I was really interested in is this initial oscillation. After 5 or 10 minutes, it really smooths out, and it gets to our final current of about 230 milliamps, and that's what we saw earlier. And when it's that current, then the voltage is really stable. It's around 8.8, 8.9 volts, which is close enough to 9 volts. But the part that's really kind of interesting to me is this part here. This is where the current is going up and down as the oven is turning on and off, trying to stabilize. And check out what happens to the voltage. The same thing. So we'll take a little bit closer look here. All of this occurs within a couple minutes. So it looks like when our voltage, what is it doing here? So when our voltage is kind of low, it struggles to keep the voltage up, the current is limited. But once it's able, presumably, to warm up enough so the voltage can climb to about 8.5 or something close to 9 volts, then all of a sudden the current skyrockets, and it goes from less than 0.2 amps to a little over half an amp. And after it's at half an amp for a little while, then the voltage is able to finally get toward 9 volts, and then the current starts to drop again. So presumably our oven has reached its goal temperature at about that time. And then it turns on and off a couple more times, so it relaxes, turns on, turns off, and then it stabilizes. So this is a pretty cool thing that I'm able to do. I'm able to monitor the power supply voltage and current using a test point. So it's not even really the power supply, it's a test point in my circuit. I'm able to measure this test point voltage and the current simultaneously, wirelessly, from a device way over there using the Bluetooth module. So all in all, this has been a pretty cool project, and I look forward to seeing what else I can do with it.